My name is Maryna Viazovska and I'm a professor of mathematics here at EPFL. I work at the chair of number theory. As a number theorist, I work on numbers, geometric shapes, and intimate connections between them. And I'm best known for the solution of the sphere packing problem in dimensions 8 and 24. A sphere packing problem, it's a very natural geometric problem. For a very long time, people got interested in this question. The basic question is how many equal non-overlapping balls can be packed into a certain volume. This question is famously known as Kepler's conjecture. For a long time, the rigorous mathematical answer to this question was missing. So it is not difficult to come up with possible optimal constructions, but it turns out to be very difficult to prove that nothing better can be done. The original Kepler's conjecture was for our familiar dimension 3, but as mathematicians, we are also interested in other dimensions. And the sphere packing problem, it can be formulated in any dimension. And mathematicians have studied this problem first in small dimensions. They have suggested possible optimal solutions, but they also developed methods for proving upper bounds. In 2003, Cohn and Elkies suggested a new method for finding these upper bounds, and they applied this method in many dimensions. And in all dimensions, they obtained some result. But in dimensions 8 and 24, their bound came very, very close to the density of existing configurations. So they did not obtain a sharp result, but it was numerically nearly sharp. What Cohn and Elkies have done, they have computed approximations, numerical approximations to this magic function. And my contribution was to find an explicit formula for it. So my work is theoretical, and at the point there is no concrete applications. However, I have hope that these Fourier interpolation formulas will have application for example, solving differential equations, maybe also for processing signals. So it was not one moment, but maybe several good ideas that in the end led to the solutions. So it was important to solve many small sub-problems and finally to get the complete solution. So I'm very honored to receive this award, and it means that people appreciate my work. It's extremely pleasant, but it also feels like a big responsibility.